Hello everyone. The topic that we're going to study today is about alkanes, alkenes, and alkynes, which is under the chapter hydrocarbons. Okay, hydrocarbons. Let us study about alkanes. So let us understand what are these alkanes. Like alkanes are like saturated open chain hydrocarbons, right? What is the meaning of saturated? So, what does the English word saturated means? It means that, you're completely full now. Suppose if you say, ma'am, I'm so saturated, I cannot study. That means your mind is fully saturated. So, saturated open chain hydrocarbons, they are. Okay. So, see, here they are saturated, right? Like no more bonds can be formed, right? And they are known as paraffins, right? Okay. Okay. Next. So they're also called you must have heard of paraffin wax, and they are, very less reactive and inert under normal condition. What is the meaning of the word inert? It means less reactive. Okay. Next is the general formula of alkanes is CnH2n plus 2. Okay, this is the general formula of alkanes. And for n is equal to 1. So if the carbon atom, number of carbon atom is 1, let us try this formula. C1H2 into 1 plus 2. So it becomes CH4, which is nothing but methane, right? Methane is also known as a marsh gas, right? So it is CH4. This is the general formula which you should know, right? It is CH4, methane. For n is equal to 2, it is C2H6, that is ethane. For n is equal to 3, it is C3H8, which is propane, right? So ethane has just single bond. Alkanes have single bond. They are saturated compounds, right? Now, all the carbon atoms here are sp3 hybridized, and I'm sure you must have heard about hybridization in the chapter 4, that is chemical bonding. So this is how it looks. Can you see? All are sp3 hybridized, right? This is methane. Okay, so higher alkanes. Now you can make higher alkanes by replacing the hydrogen with CH3. Now suppose if I remove one hydrogen and instead of it I put CH3, I can make higher alkanes, right? I can continue doing this and I will get more and more higher alkanes, right? Okay, now let us go through the physical properties of these alkanes, right? So, these are non-polar and hydrophobic in nature. What is the meaning of the word polar? That means there is no charge separation. See, carbon is not electronegative, hydrogen also is not electronegative. So they are not polar. Let me tell you water molecule. See, you must have studied this in chapter 4. Oxygen is very electronegative, hence is that it has a partial negative charge and hydrogen has a partial positive charge. Because of this electronegativity, the bond pair of electron is more towards the oxygen, right? So there is a shifting of the the bond pair of electrons towards the oxygen. Now this is known as polarity. So there is kind of a polarity or a charge separation in the water molecule, which is not here in the case of alkanes. So they are non-polar. What is the meaning of hydrophobic? See, hydro means water, phobia means fear. That means they are not miscible in water, do not dissolve in water. Alkanes, like, our plastic bottles, they are also alkanes. And as you all know, plastic does not dissolve in water because they do not have polarity. To dissolve in water, there should be certain polarity, right? Like hexane and water, even if you mix, can you see it is just like a layer of oil in water, right? So it is not soluble in water. Okay, alkanes are not at all soluble in water, right? Okay, let us move forward. Okay. And at room temperature, basically carbon atoms C1 to C4, they are gases. And C5 to C15, they are liquids. And C18 onwards, they are solid, right? Because when there are less carbon atoms, the force of attraction is also less. Okay. Now let us move forward. So they are colorless and odorless. There is no odor in them. There is no smell. There is no color. Okay. So let us move forward. So, okay. Now boiling point. So their boiling point increase with the increase in the molar masses, right? Because obviously if the mass is more, it will take more amount of energy to boil that, hence the boiling point will also increase, right? So basically the forces of attraction between them are van der Waals forces. So if we increase like as I told you, if you increase the number of carbon atoms, the van der Waals forces would increase, right? Which is why it is becoming from gas to liquid and then liquid to solid, right? Okay, and if you increase the number of carbon atoms, if you increase the mass, so obviously the boiling point would increase because it depends on the mass, also the surface area. So suppose if I consider CH4 and if I consider C2H4. So C2H6 ethane. C2H6 has a larger surface area, right? So this will have more boiling point. Okay. Okay. Now, if there are branching, like if there are same number of carbon atoms and if there are branch chains, so the branch ones would have less boiling point because of the less surface area. Okay. Okay. So let us see what are, alkenes. Alkenes are unsaturated hydrocarbons. What are unsaturated means there is still certain, you can break the double bond here and add more amount of any compounds, any element you can add here. You can add more hydrogens, right? These are known as olefins. Okay. These are oil forming compounds. So first member is ethylene, or ethylene is like a common name, but the IUPAC name is ethene, right? Can you see ethene C2H4? There's a double bond. So this is how it looks like, the double bond in alkenes. Basically, can you see these are the two carbon atoms? And if you would see how they are like, coming close and forming the bonding, can you see? I would just replay this. See. So basically the double bond is formed because of the head-on overlap of sp2 orbital forming a sigma bond. This is the first bond. Now the second bond, the second bond, there is a pi bond is formed because of the lateral overlapping of the p orbitals, right? Yes, so this is the structure of the double bond in the alkenes, which you have studied in chapter 4, right? That is the chemical bonding chapter. So we have one sigma and one pi bond, right? And the hydrogens are attached to the carbon atoms, right? Okay. So basically it consists of one sigma bond and one pi bond. And sigma bond, as I told you, it is formed due to head-on overlapping. And pi bond is formed due to, lateral overlapping of the p orbitals. If I would show you, this is a pi bond, which is lateral overlap. This is the head-on overlap of the sp orbitals, and this is the sigma bond. So if I would draw this C2H4, so I can say that this is pi and this is sigma. Okay. Let us move forward. So, pi bond is generally weaker. Okay. Okay. So, due to the presence of pi bonds, alkenes are more reactive than alkenes because pi bonds are present. Pi bond means more electron density. Okay. Now, let us study about alkynes. Okay. So, if you are studying about alkynes, alkynes are again unsaturated open chain hydrocarbons. What is the meaning of unsaturated? That yes, there is a tendency now to, add more hydrogen atoms. Now, alkynes, they have a triple bond. Okay. So whenever triple bond is present, we call them alkynes. See, the general formula is CnH2 and -2. So for example, if I put C with one carbon atom, alkyne is not possible. If I put C, N is equal to the number of carbon atoms. If I put C4, H2 into 4 minus 2, it becomes C4H8 minus 2. So it becomes C4H6. Okay. So let me draw that. So if I would draw C4 and I want to draw like a triple bond. So isn't it? Now you need to check that all bonds are satisfied or not. This carbon is satisfied. It is making 4 bonds. Each of these carbons are also making 4 bonds. Carbon can make 4 bonds and it has to make 4 bonds to become stable, right? So this is, what will be the name? The name would be butane. And to be specific, the name would be butane because the double bond is present on the second carbon atom, right? So the first member is ethine, which is acetylene. Okay, so it is very important for us to know the common name acetylene as well. It is used for the welding processes, the welding purposes. If you would have seen welding happening somewhere, so they use this gas, which is acetylene. Okay, so let us see the bonding. Very interesting. It is see how there is a head-on overlap forming a sigma bond. Then there are 3 p orbitals, right? Py, pz, and px. Let us see. See, there are 2 pi bonds being formed, right? So if I have like ethine, so in ethine, the middle bond is the sigma. Then I have pi and pi bond. Pi bond is formed due to overlap between the p orbitals. Can you see? Between pz, one pi bond. Between p pi, one, pi bond. Okay. So, and hydrogens are bonded at the end with the sigma bond, that is a head-on overlap. Okay. So here we have 2 pi and 1 sigma, right? This is ethine. What are the physical properties of ethyne? So at room temperature, again, C2 and C4 are gases, C5 to C12 are liquid, and from C13 onwards, they are solids. Okay. These are because of the, again, van der Waals forces of attraction increases. So obviously, slowly they turn from gas to liquid to solid. Next, all alkynes are colorless, they are odorless, they are insoluble in water. Can you see alkyne in water? They are insoluble in water. So they are fairly soluble in non-polar solvents. See, in case of solubility, we need to understand one thing, that like dissolves like. So any polar solvent would dissolve polar substances. Like NaCl is polar, there's a charge separation. So it can dissolve in water molecule, because I showed you the polarity in water, right? But like any hydrocarbon, alkane, alkene, alkyne, they are non-polar. So they would dissolve in non-polar solvents like benzene. Benzene does not have any polarity. You all know the structure of benzene, right? It is this. Okay, this. So that means my C2H2, my ethine, can dissolve in benzene. Okay. So their melting point, boiling point, density all increase with the increasing molar mass and the surface area. So I really hope you would have understood about the basic properties of alkane, alkene and alkyne. Let us revise it. Alkane is unsaturated. Alkene and alkyne are, alkene and alkyne. Alkane is saturated, fully saturated, single bond, no more hydrogens or any other element can come up. Alkene and alkyne are unsaturated compounds, right? And we studied about their general structure. Alkene has a single bond, alkene double bond, alkyne has a triple bond, right? And then we also studied about their melting point, which depends on the mass and the surface area. If the surface area and the mass increases, the boiling point also increases. We check their geometry and the bonding, also the orbitals that are involved in the bonding. So I hope you understood about the alkanes, alkenes and alkynes in detail. Okay, so if you have any doubts, we can, connect through Urban Pro. We can take classes and solve the doubts, study this chapter in detail. Thank you so much for paying attention. I really hope you understood about alkanes, alkenes, and alkynes. Thank you.